Every AI app needs data. Your files, your databases, your Slack messages, your GitHub repos. And right now, every single one of those connections is custom. One wrapper for Google Drive, another for Postgres, another for Slack. Each one built from scratch, maintained separately, and ready to break the moment something changes. It's a mess. And it gets worse with every new tool you add. This isn't just ugly, it's expensive. Every AI product team rebuilds the same integration patterns. Slack connector? Built it. GitHub connector? Built that too. Database access? Another custom wrapper. And every other team building an AI app does the exact same thing. 10 tools, 5 AI apps, that's 50 separate integrations to build and maintain. It doesn't scale. This is where MCP comes in. Model Context Protocol, an open standard from Anthropic, introduced in November 2024. You still need a server for each service. That doesn't change. What changes is how they connect. Say you have one AI app. It implements one MCP client and connects to every server through the same protocol. Now a second app comes along. It doesn't rebuild those integrations. It just speaks MCP and connects to the same servers. A third app, same thing. Build the server once, and every app that speaks MCP can use it. 10 tools, 5 apps, that's 15 implementations, not 50. Here's how it's structured. MCP has 3 roles. The host is your AI application, Claude Desktop, an IDE, whatever runs the model. Inside the host, a client manages the connection. And on the other end, servers expose what the model can access. Each server offers up to 3 things. Resources. That's your data. Files, database records, API responses, screenshots. Tools. Those are actions. Search, create, update, run code. And prompts. Reusable templates that guide how the model works with the service. All of it travels over JSON-RPC 2.0. Simple request, simple response. So what does this actually look like? Say you're building an AI agent and you want it to read Slack messages. First, your app needs an MCP client. That's the piece that speaks the protocol. It's built into apps like Claude Desktop and many IDEs, or it's a small library you add once if you're rolling your own. With the client in place, connecting a new server is just configuration. You add one line pointing to the Slack MCP server. Now your agent can discover what tools are available and call them. It sends a request. Read the last 10 messages from the engineering channel. The server handles it and sends back the data. That's it. No SDK. No custom wrapper. No 2-week integration sprint. And the same pattern worked for every server. Databases, file systems, cloud storage, dev tools. Anthropic shipped early servers for Google Drive, Slack, GitHub, Postgres, and more. The community built hundreds more. Your agent just speaks MCP, and the ecosystem does the rest. But here's the thing. MCP can touch real data and run real actions. That means security matters. The official spec is clear. Tool invocations can mean arbitrary code execution. Servers need consent gates. Clients need to verify what they connect to. Researchers have already identified real risks. Prompt injection through tool descriptions, tool poisoning, and lifecycle attacks where a server behaves well during setup, then turns malicious later. This is powerful infrastructure. It needs to be treated that way. Think about what USB-C did for physical devices. One cable, every device. MCP is aiming for the same thing, but for AI and data. One protocol, every tool. It's not there yet. Adoption is growing, the spec is evolving, and there are real security challenges to work through. But the direction is clear. A world where connecting an AI app to a new data source is as simple as plugging in a cable. One app, one protocol, many servers.